Hello, this is a video response to a YouTuber on the globe side called Bball4Life. This is his channel down here. I'll link this video in the description. This is showing an effect that I've seen many times from the globe side that they call, on that side of the argument, they call outcurve, where they're viewing something but there is water in the way of their view. Now, this is very strange because on a globe or a sphere shape, wherever you stand, everywhere should fall away from where your feet are. So the old adage that things go below the horizon and disappear below the horizon, this debunks that as it stands in contradiction, these kind of claims. As something going below the horizon is different from something coming up in front of your view, as this is what this is. There's an obstruction in the view that's coming up the way, as opposed to what we're looking at going down the way. But the actual reason for this is not our curve. I've seen many of these videos, and they're always. I don't think I see too many of them from the northern part. From north of the equator. It's mostly in the south of the equator, in Hawaii and Australia and places. As that they have a very deep, Hawaii and Australia and places like that in the south. Whatever it is about the south, I think Africa, New Zealand is the same as well, where they have a situation where there is the topography underneath the water is very deep, not too far from shore. So there's not a gradual drop off so much as there is in the north. More often in the north there's a gradual drop off, but in the south it's more often that, especially around Hawaii. I see a lot of them coming from Hawaii and Australia, Western Australia. I don't know about Eastern, but Western I see. And what it is basically is what's known as shoaling. It's an effect that happens. It's a real thing, but it's an effect that happens because of the topography underneath the water. I'll just show you now. So this is shoaling. I'll just read a little bit about shoaling. Shoaling is an increase in wave amplitude that happens when water waves, not just tsunamis, go from deep to shallow water, particularly at the coast. Tsunamis have a small amplitude in deep water, often much less than a metre, but they can shoal up to many metres high in shallow waters. For New Zealand, a small tsunami could run up to 10 metres high, higher than normal sea level. That's about the height of a 3-story building. In the 2004 Boxing Day tsunami, there were waves 15 to 30 metre high. Surf waves also undergo shoaling. They have a greater amplitude than the ocean swells they form from. They shoal much closer to the coastline than tsunamis, and the proportional increase in height of their wave crest height is much less. Why shoaling happens? Waves get slower, shorter and higher. Shoaling happens because waves experience force from the seabed. As the water gets shallower, this slows down the wave. The shallower the water, the slower the wave. So what happens is that you have a deep drop off not too far from shore in places like Hawaii. And what happens is that when the tide is coming in, you have the waves, the length between them becomes shorter, they become higher and they become slower. So you end up with an obstruction. This is what happens, because you end up with waves that basically well up. It basically causes the water to well up and go up in the air, basically, because it's water. Although it is liquid, it has a certain density, and it does have a gluey effect due to the hydrogen bonds. So it does do that. That's why when you pour water into a cup up full and leave it flow out on a level surface, what will happen is that it'll be all flat at the top, but around the edges there'll be a small little curve. Okay, this is what water does. It finds its own level, but it does have an ability to nearly stick together in some ways. That's why you have such a thing as a droplet that's on something. Do you know what I mean? You can have droplets on something, like condensation, many small droplets. It sticks together That's what, because of the hydrogen bonds. But either way, what happens is that because of the big volume of water from the deep hitting the shallower portion, in the shallow area near the shore, it's in places like Hawaii, what happens is that the water wells up, so it causes an obstruction in view. Now, it wouldn't be always noticeable straight away, but it's obvious that Hawaii gets a lot of big waves and a lot of high tide waves, as if you know what I mean. There's like surfing is big in Hawaii. I think surfing came from Hawaii, and part of the reason is because of the topography around Hawaii. That's part of the reason. Because of what? Because of shoaling. Shoaling is a big part of it. People who know surfing will know about shoaling. It's one of the things they'd have to know. If they've been into surfing for any length of time, shoaling will be important. If they're watching the waves and watching the water, shoaling will be a big important part, especially in the southern hemisphere. Although that's an oxymoron, it's still what we call it. In the south of the equator, let's call it. Now, I'm just going to show here. I'm just going to bring this one down. This was Bball4Life's location. He said he was at 8 foot, but he was right here. It says 9 foot, 8 foot. About here he was, about the edge. He said 8 foot elevation, and he had a camera that was about almost 2 feet. I say, let's get 2 feet. So we give him 10 foot elevation. So we'll say he was at 10 foot elevation with the camera. It was 8 foot at this point, and another 2 foot on top of that for 10 foot. So we give him the extra 2 foot. It doesn't really matter. This is the Harbour Island tide chart. Okay, for the 15th, which was the date of this video. This is the 15th of July. This is his fourth one. I've heard him speak online. He's done it several days in a row. I don't know the other three. I just saw this one, so I said I'll go with this one. I haven't looked at those, but he's done them all within a short enough space of time. But he was there at 11:48. He was definitely there at 11:48 in the morning. And this is 1:23. This is at full high tide on that same day. So the tide was coming in. So the tide would have been coming in and shoaling would have been happening. There's no way around that. It would have been happening. And there's 1.88 meter tide here, or sorry, foot, 1.88 foot tide at full high tide at 1:23, which would be about an hour and a half after he was there. And if we look at this is for Wednesday, July the 15th at 12 o'clock in the day, which would be about 12 minutes after it shows. I know there's a marker on his video, it shows it's 11:48 on one of the things he shows, so I'll take it he was there at 11:48. He's looking in this direction, and the red here is showing, when you see red, you're talking 3.5 to 4 foot waves. So you have almost 2 foot almost 2 foot tide, and you have waves that are wave height that's 3.5 to 4 foot happening across this way. So if he's at around 10 foot observation height, and you're going to talk about 5 and 6 foot is going to be obstructed, or you're talking 4.5 to 6.5 foot obstructed. So if he's at 10 foot elevation, and this is around here, be his center screen, you're going to have obstruction at the bottom. That's just the way it's going to be. He's not going to see directly straight across in those conditions. It's just not going to happen. And I'm going to show something now that he knows about himself, because I know he showed it himself, if I remember right, on Jose's. It's called visual occultation. So just some photographs. So watch as I move this bottle in front here back a bit. So move it back, and you can see it's showing a bigger bottle at the bottom, but it occults it the closer it is to me. So even though, I'll just go back there, you can see how much bigger that bottle at the back is. But even though this bottle is smaller, because it's in my eye line or affecting my view, then it causes the background bottle to appear to be smaller than it really is. But it's not that it's smaller, it's just an effect of perspective. It's called visual occultation. Some people call it photographic occultation, because for people who are professional photographers would know about it. But this is what it does. As you can see, and he knows about this, Bball4Life, if I'm correct. So you can see, I'm going to go right up close. If I moved it over to the left of the screen here, it would completely block that ball. Even if I moved it over to the left of the screen, now you won't know there's another ball behind it. You know, even there, if I moved it over, you'd notice something black behind it, you wouldn't even know it's a ball. So this is what visual occultation is. So what's happening to him is he has his vision being occulted by basically the incoming tide, and it's swelling up, wave shoaling basically, because of the topography underneath the water. As it comes in from a deep position into the shallow area on the shore of Hawaii, what happens is it wells up. This is what it does. So this is what he's seeing this. And the reason that's blocking things that appear to be bigger in the background is purely down to visual occultation, something that he knows about himself. So that's the reason for this. Because if something is coming up in your obstruction, and it can be at different heights, then it can't be Earth curve for a start. Because Earth, we're told, is basically a sphere. This is what we've been told. Now, obviously I don't believe it, I'm flat out, but this is what we're told. If you stand on a sphere, regardless of its size, it will always fall away from everywhere from your feet. Wherever your feet are, it should be falling away in some direction, in all directions at some dimension, at all times. If you could stand on a giant basketball, it will be falling away from your feet. So this is the problem. If things are coming up as an obstruction, they can't be Earth curve. They can only be something else. Earth curve would have to fall away from your feet. This is why the old, although it's totally debunked now, the old, due to black swan photographs, the old boats going over the horizon thing, that means that they should be getting lower. They should be basically going over something and going down over something. And this is what we were told. So how could that have ever been true if something can also come up? I think on the ball side, they really need to make a decision on whether our curve is going down or coming up in front of you. Either it's going down away from you or it's coming up in front of your vision, because it can't do both. You know, it's not mutating. So I think on the ball side, you need to make that decision on whether or not it's coming up or going down. Okay, thank you. If Bball4Life wants to reply to this, he's welcome, of course, and I will welcome it. Where is the thing? Okay, thanks, bye.